Hello everyone, my name is Lauren Temez. I am a mechanical engineering major at Wayne State University. I'm currently taking this class BE 2100, Probability and Statistics, and I'm going to be going over this problem on confidence intervals on the mean. So, suppose that a random sample of 36 bottles of a particular brand of cough syrup is selected and the alcohol content of each bottle is determined. Sample mean is calculated as 8.6 and population variance, true variance, is known as 16. Compute a 90% two-sided confidence interval for the population mean, true average of alcohol content. So what are we even doing here? We're finding a two-sided confidence interval for the population means. That means that we are going to be 90% sure that the population mean is within certain bounds. So it's going to look like this. Sample mean minus error is greater than or equal to population mean, which is greater than or equal to sample mean plus error. And error is z of alpha over 2, I'll explain that in a second, times deviation over the square root of n. So what does all of this even mean? So this is what our confidence interval is saying. It's saying that they're 90% sure that the mean is going to be somewhere in here. And this is our mean. So going out this way is our minus error, and then going out this way is our plus error. And this is why we have the z of alpha over 2, because this is a two-sided confidence interval, so it has two tails, and alpha has to be split up into 2. So how do we figure out this value? Well, first we need to calculate alpha, which is just the complement of our percentage here. So our alpha is 0.1, which makes alpha over 2 0.05. So now we have to find z of 0.05. So what this means is this shaded in area is 0.05. So we need to find this on our z table. So I go to my z table that I have here, and you can see that this isn't the area that's shaded in. The area that's shaded in is over here, because this shows cumulative. So the easiest way to do this, due to symmetry of the two tails, you can look up where this value is 0.025 and then just use the positive value, because the positive value will be the same distance on the opposite end. Did I say 0.025? We're looking at 0.05, an area of 0.05 right here. So that's going to be right here. This is our closest value to 0.05. So this puts us at negative 1.6. We read from this left side, this left column, negative 1.6, and then we look at the top of the column, 4. So negative 1.64, And we can just use the positive value of this since it's going to be over here, and it's going to be the same distance. So C of 0.05 equals 1.64. So let's look at the other values that are given to us. They give us a random sample of 36 bottles. So sample size is 36. So N is 36. We're given the sample mean, which is X bar, and that is 8.6. And we're also given variance, which is sigma squared equals 16. So now we can calculate error, which is z of alpha over 2, which is 1.64, times the square root of our variance, because we just need deviation. So square root of 16 is just going to be 4, divided by square root of n, which is square root of 36. And this will give us 1.093. So we can plug in our values here. We have 8.6 minus 1.093. 8.6 plus 1.093. And this gives us our confidence interval of 7.507 is greater than or equal to mu, which is greater than or equal to 9.693. And that is our 90% two-sided confidence interval for the population mean.